Alright, find the range of values of p's for which the line y equals to px plus 10 intersects the curve at real distinct points, and the curve has got this equation. Okay, that means you got to use the discriminant. The discriminant b squared minus 4ac must be greater than 0. Alright, so let's start off with a. Let's try to do a. So we know that y is equals to px plus 10. Okay, and the curve has the equation 2x squared minus x, y is equals to 5. Well, the good thing is that y is already the subject here, so we can just sub y into this other equation. So 2x squared minus x, let's perform a substitute since y is equals to px plus 10, so this bracket here is px plus 10 equals to 5. Okay, very next line, let's perform expansion. Okay, minus x times px equals to minus px squared. Okay, minus x times 10 equals to minus 10x equals to 5. Okay, so 2x squared. Okay, now you realize we've got two terms with x squared, so we can lump it into one term because x squared is the common factor, so we can extract x squared 2 minus p, okay, minus 10 x minus 5 is equal to 0. So 5, I shift it to left hand side of the equation. Okay, let me rewrite this as 2 minus px squared. Okay, I think you probably understand this better than this. Minus 10x minus 5 equals to 0. Now, can you see that it resembles the quadratic equation ax squared plus bx plus c? So this is a quadratic equation. Okay, EQN for equation. Alright, can you see ax squared minus or plus bx plus c? Alright, so it resembles a quadratic equation. Now when we have worked it out to this extent where it looks like a quadratic equation, we can use the discriminant. And since it's got real distinct points, we have to use b squared minus 4ac. It has to be greater than 0 in order to have real distinct points. Alright, b happens to be minus 10 squared minus 4, a is 2 minus p. Well, c is just minus 5. Okay, it's greater than 0. Okay, let me work this out. Minus 10 squared is equal to 100. Okay, minus 4 times minus 5 will give you positive 20 is 2 minus p greater than 0. We move up here because of lack of space. Okay, 100. Expand this. 20 times 2 will give me 40. 20 times minus p. So this is 40. 20 times minus p will give me minus 20p is greater than 0. Okay, 140 minus 20p is greater than 0. Okay, 20p is less than 140. Okay, maybe I'm just skipping steps here, so let me do it without skipping steps, alright? So that you can understand better. Minus 20p is greater than minus 140. Okay, what I do is I divide throughout by minus 20. When I divide by a negative number, the sign changes. Minus 140 divided by negative 20 would give me 7. So p has got to be less than 7, so this is your answer. Okay, let's do b right now. Find the smallest value of the integer c such that 4x squared plus 7x plus c is positive for all values of x. Okay, well, what they are trying to say here is this, okay, quadratic expression, a quadratic curve, is positive for all values of x. That means for all values of x, well, this is the x-axis, it's always above the x-axis. Alright? Okay, it doesn't ever touch the x-axis, so none of the curve is less than 0. Alright, it's always greater than 0. That's what it means. Alright, so 4x squared plus 7x plus c. Okay, they want to find the smallest value of the integer c. Okay, so since it's got no roots, okay, we use b squared minus 4ac, the discriminant, to be less than 0. So in this case, b is 7 squared minus 4a, a is 4, and c is just c. Alright, in this case, less than 0. 7 squared is 49 minus 16, c is less than 0. 49 is less than 16c. c is greater than 49 over 16. c is greater than 3 and 1 over 16. Since you want the smallest integer of c, okay, now this is not an integer, okay, so you're going to round it up to 4. So c must be at least 4. c is definitely 4, alright? Okay, because this is a mix. This is the smallest integer you can possibly be, because if you draw a number line, this is say 2, 3, okay, 3 and 1 over 16 is here, alright, and this is 4. Okay, so since it's greater than 3 and 1 over 16, okay, so if you extend this way, so it's got to be 4. Alright, so the answer is 4.